Okay, we were discussing condensation polymerization. Condensation polymerization can be natural or it can be artificial or synthetic. Or it can be natural. Last we discussed the synthetic polymers such as polyamide, which is also called nylon, and polyester, which is also known as styrene. Today we'll discuss condensation polymerization, natural condensation polymers. In this, you will learn the structure of how a protein is formed, carbohydrates, and fats. So we'll discuss the formation of these natural condensation polymers. Protein is also a condensation polymer. Carbohydrate or starch here is also a condensation polymer. Fats, a molecule of a fat, is also a condensation polymer. So first we start with protein, formation of a protein. For formation of the protein, what are the monomers? Are amino acids. So many molecules of amino acid are the monomers. What is amino acid? You can understand from the name. Actually, it's a combination of two groups, amine and acid. So amine means NH2 and acid means the carboxylic acid, which is C double bonded with O and OH. So what is the structure of amino acid? These amino acids, so it contains like many molecules of amino acid. So this group is called amine and this is known as acid. So a molecule which contain both amine and carboxylic acid, we call them as amino acids. The two types of polymerization can be addition, can be condensation. Addition is always synthetic. Condensation can be synthetic, means man-made, or it can be natural. Man-made, this is what we are preparing a polymer. This is in nature, a polymerization reaction occur, which result in a formation of a polymer. So we are discussing, because we already discussed the artificial condensation polymer. So we are discussing the natural condensation polymers. So the first one is the amino acid. What is amino acid? It's a protein. Protein is actually formed by many molecules of amino acid. And what are amino acid? If a molecule contain amine group and carboxylic acid, we call them as amino acid. So if we draw the monomer, amine group is there. Amine group means NH. And carboxylic group is there. Carboxylic group is there, C double bonded with O and OH. Between them, how they're linked with each other, the two functional groups, the two groups are linked by a carbon chain. So between them, there are carbon atoms. But again, instead of drawing these carbon atoms, what we can do, we can use a symbolic representation. I can use any symbol. Example, I use a box. What this box shows, it shows there are carbon atoms between them. Maybe 5 carbon atoms, 3 carbon atoms, 2 carbon atoms. But it's because it does not make difference to the formation of a protein. That's why it is not necessary to mention these carbon atoms. So we use a symbolic representation. This is one molecule of amino acid. Then there's another molecule of amino acid. And between them, there's a carbon chain. So we use a symbolic difference. If they're identical number of carbon, we'll use the same symbol. If they're different number of carbon, we'll use a different symbolic representation. This is also amino acid. I'm drawing the monomer. So this is also amino acid. And another amine group is there. And acid, that's also amino acid. So all of them are monomers, small molecules. Now, how a polymer is formed? To form a condensation polymer, because the water molecule must be released, and there are so many, like example, repetition is there. I just draw only 3 of them. So what happened? Amine will lose its hydrogen and carboxylic group. Amine will lose its hydrogen and carboxylic acid will lose its OH. Amine will lose its hydrogen, carboxylic OH. Amine will lose its hydrogen and carboxylic OH. So one side hydrogen is removed and the other side hydroxide is removed. And this will result in a formation of a polymer, which is known as protein. And this is naturally occurring polymer. That's why we call them as natural condensation polymer. Now the structure of a protein. So if we draw the structure of a protein, this H is being removed. So this is NH. Then there's a box. What this box represent? This box represent a carbon chain. Then C double bonded with O. This OH and H being removed. So we have nitrogen bonded with carbon. Then this box. Then C double bonded with O. This OH is being removed and H is removed from nitrogen. So what we have nitrogen high and formed in a bond with carbon, and C double bonded with O. And because it's a continuation, so if it's a continuation, what we will put? We will put N, means it is a continuation. And what is this structure? This is a structure of protein. What type of linkage is this? C double bonded with O and N. What kind of linkage or bond is this? What is this bond known as? This is called amide bond, amide linkage, or peptide linkage. That's correct. So the same type of linkage is there in nylon as well. But the difference between nylon and protein is, nylon is a synthetic polymer, means man-made polymer, whereas protein is naturally occurring polymer or polymer formed naturally. And the second difference is, the second difference is that when you check the monomers, if you remember for nylon, we have two different types of monomers, like dicarboxylic acid and diamine was there. But in this case, we have amino acid, identical monomers are there, like all are amino acid, and they link with each other, form a long chain compound. And natural condensation polymers are reversible. Reversible means, like, if we have amino acids, amino acids can form a protein, which is called polymerization, and protein can be hydrolyzed to form amino acids. So both can happen. Amino acids can turn into protein, and protein can be hydrolyzed, result in formation of amino acids. Yeah, this is a formation of a polymer. Amino acids link together and form a long chain compound. That's a polymer. Is it clear? Any doubt in this part? Copy the structure for what will happen to H and OH, because H and OH will join together, and this is why we call a condensation polymer, because it results in a formation of water. Because in a condensation polymerization, when monomers link together, as a result, they form a long chain compound, the polymer, as well as a small molecule is released, that is H2O, because one side you remove H, another side OH or OH and H. This will result in a formation of water molecule.
Sir, the acid in amino acid is carboxylic acid.
Yes, finished drawing the structure. So if I write a word equation, for this, so we have, this is a word equation for this: amino acids plus amino acid So when amino acids join together, they will form protein plus water. And this reaction, formation of a protein, this is called polymerization or condensation polymerization. And the reverse, if a protein is breakdown into amino acid, what we call reverse reaction, we call that as hydrolysis. This is a word equation, like, and it's like, it can be two amino acid, it can be many molecules of amino acid, and they join together, result in a formation of a protein. The second condensation polymer is carbohydrates. Formation of the carbohydrate. So what are the monomers? So the monomers here for carbohydrate are many molecules of diol. So monomers for carbohydrates. Yeah, the glucose molecule, that's true. You can mention glucose, but basically these glucose are diol. So what happened? That the term diol means two OH groups are there. So if I draw the structure for the monomers, so what are the monomers here? We have diol, the di means two, so two OH groups are there, and between them there's a carbon chain, but that's not important like for the structure. That's why we can just use a symbolic representation. Then there's another molecule of a glucose, and between them there's also a carbon chain. Then another molecule of a glucose. Because in the polymerization, condensation polymerization depends on the ends of the molecule. That's why it will not make any difference what is there in the center part of the chain. So many molecules of glucose or diol. Now, how it will form a polymer? These are all monomers. I drew the monomers. Now I will draw the polymer. So how it form a polymer? If one side it loses H, other side it will lose its OH. Or if the first one you remove OH, if the first one you remove OH, the second one should be H. Then OH, H, OH, H, OH, H. So it's up to you which one you want to remove first. If the first one I select H, then the second end OH because formation of water. Then H, OH, H, OH, H, OH. Now what will be the resultant polymer? That's carbohydrate. But what will be the structure of this? So there will be O, this oxygen, then this linkage is there. Then this OH and H is being removed. So if I remove OH and H, so what I'm left with oxygen. So O will be there and there's a carbon link. Then this OH and H being removed, so oxygen is there. And then there's a carbon link, like the carbon chain. And this OH H being removed. So what I will have oxygen and then this carbon chain. And because it is a polymer, so it means it's a continuation, it's a long chain compound. So we will put N plus The water molecules are also given off because HNOH result in a formation of H2O. So this is the structure of carbohydrate. The forward reaction in which the glucose molecule form carbohydrate we call polymerization, and the reverse reaction is known as hydrolysis. So the forward reaction is polymerization, whereas reverse reaction is known as hydrolysis. Is it clear? This formation of a polymer by reaction of glucose molecule. Yes, I will write the equation as well. Like you have many molecules of glucose. Why it is known as a diol? Because the di means two, okay? And all means alcohol or OH group. You can see it's having two OH groups at the end. That's why we call that as diol. So in this case, we have glucose molecule. So glucose molecules result in a formation of carbohydrate plus water. Is it clear, this structure, formation of carbohydrates? Copy this structure. If any question, you can ask your question or doubt. What about others? Everyone finished this carbohydrate structure? The last one is the formation of fat molecules. So basically, what is a fat? It is formed by when glycerol, which is also a triol. So glycerol is a triol. Tri means three, and all means OH groups are there. So when glycerol reacted with fatty acids, this will result in a formation of, and what are fatty acids? Fatty acids are carboxylic acid. This will result in a formation of fat, the polymer, plus water molecule. So the forward reaction is known as polymerization. And the reverse reaction is known as hydrolysis. Normally, when we hydrolyze these natural polymers, we either use acidic or alkaline condition to speed up this hydrolysis. Otherwise, if water is there, a neutral water, a pH 7 is there, hydrolysis process is not efficient, it is very slow. So we normally use either acidic or alkaline condition to hydrolyze these compounds. So glycerol, which is triol, react with fatty acid. This is result in a formation of a fat. So what is glycerol? A triol. When we say triol, tri means three. So three OH groups are there. Till now, they never ask the structure of the fat. Normally, a word equation is there and some indirect questions, but till now, they did not ask, draw the structure of the fat molecule. So glycerol is triol. This is a structure of glycerol. And what is fatty acid? Fatty acids are carboxylic acid. So they have C double bonded with O and OH. C double bonded with O and OH. And C double bonded with O and OH. And what is there with the carbon? It's a long chain. So instead of drawing that chain, we just use a symbolic representation. So carbon is linked here. So this one is glycerol, which is triol. So what happened, how a polymer is formed? These are known as a fatty acids. And this one is glycerol. So what it result? If one side, if we remove H, the other side OH. Or if one side we remove H, the other side will be OH. And same thing, if I remove H from here, the other side will be OH. So how they link with each other? When we draw the structure, the CH2 is there, the CH is there, then the CH2. What happened? This H and OH is being removed. So this circle means H and OH being removed. So there will be O. and this OH and H being removed. So this will be C double bonded with O, and this carbon chain is there. Same way, this H and OH is being removed. So we are left with O, C double bonded with O, and this carbon chain is there in a yellow shade. And the last one as well. So C double bond, OH and H is being removed. So there's O, then C double bonded with O, and there's a carbon chain in a gray shade. Plus, because H and OH, what it result? It also result in a formation of water molecules. 3 water molecules are there. So 3H2. Why 3? Because HOH1, OHH1, and so total makes 3. And what is this called? This is called fat, a molecule of a fat molecule. And this link, this bond C double bonded with O and O, this is called ester linkage. So we find the same linkage in polyesters. So fat molecules in polyester have the same linkage. The forward reaction is known as polymerization, and the reverse reaction is known as hydrolysis. So forward is polymerization, reverse is known as hydrolysis. So hydrolysis of the fat molecule will produce fatty acid and glycerol. So that's why maybe you heard Chinese therapy to lose the weight. So in Chinese therapy, what they suggest, you should drink warm water, not hot, not too cold. It's a warm water. So when you drink lot of water, warm water, how it will help? You can see the water molecule break down this fat molecules, and it will produce fatty acid and glycerol. So amount of the fat in the body will decrease. Is it clear? This formation of the fats? If we carry out this hydrolysis in alkaline medium, like example in the presence of sodium hydroxide, so what will happen? So as we know, fatty acid, glycerol plus fatty acid react together and result in a formation of fat molecule plus water. But if we carry out this hydrolysis, if we do hydrolysis, this will result in a formation of fatty acid, which is carboxylic acid and glycerol. But what happened? if we carry out hydrolysis of fat in alkaline medium or in the presence of alkali. So what happened first when we hydrolyze the fat? No, alkaline and acidic medium, the reactions are relatively faster as compared to neutral water. So first, when we hydrolyze the fat, it will result in a formation of fatty acid and glycerol. So first, what happened? Result in formation of fatty acid and glycerol. Then what happened? Because fatty acid, or because we are carrying out, what will happen if we carry out hydrolysis in alkaline medium like sodium hydroxide, NaOH, or in the presence of alkali? So what happened? Because fatty acid is an acid or a carboxylic acid. So the fatty acid will react with alkali, form a soap. So this is how a soap is manufactured or prepared. So first, like using animal fats, they hydrolyze the animal fat. When they hydrolyze the animal fat, this result in a formation of a fatty acid. And this fatty acid reacted with sodium hydroxide, because fatty acid is a carboxylic acid. Like this is C double bonded with O and OH. And there's a carbon chain. This is a fatty acid. So what happened? This fatty acid will react with what? It will react with sodium hydroxide. So when it reacts, it's a neutralization reaction. So sodium will take position of hydrogen. Hydrogen take position of sodium. So what it result? This will result in a formation of C double bonded with O and Na plus H2O. And what is this C double bonded with O and Na? That is actually a formula for soap. So fat molecules are hydrolyzed to produce fatty acid. Then this fatty acid reacted with sodium hydroxide or any alkali. This will result in a formation of soap. Is it clear? So you have to know this result for hydrolysis of the fat result in a formation of soap molecules. Neutralization reaction, when acid react with an alkali. Acid is reacting with an alkali. This is a neutralization reaction. So first hydrolysis is there and then neutralization. In neutralization,